Thank you for joining the post-lunch session. My name is Anjali Ganpule Rao, and I'm chairing the session for today, the session about innovative methods. So we are already aware that we are slowly shifting from food systems to sustainable food systems, where we have to think not only about humans, but about overall planetary health. And we are affected by different challenges. There is urbanization, there is climate change effects, there are multiple challenges. And so we have to think about new methods to collect the evidence so that we can think about actions. Today in this session, we have representation from different parts of world, different universities and different programs where people are working on innovative methods. There is a slight change in the sequence. So I would request, uh, gr- uh, I would request to shift the first session towards the end as the speaker had just arrived at the airport. So we will give him some time to settle down. And I will request Gregory Cooper, the first person to speak. He's from University of Sheffield, and he's working on the defining the NutriShed, a framework to access resilience, key nutrient flows in the urban food system. We all are aware that urban food systems are already taxed and there are multiple challenges. So let us look at what Gregory has to speak about it.
Thank you, Anjali ji. Hello, everybody. It's wonderful to be here today. I am part of just a small team, I'm a small part of a wonderful team at the NutriShed project, and it is an Amana grant-funded project, a collaboration between the University of Ghana and the University of Sheffield. Just to jump straight into the rationale, for the first 10 seconds, I just want you to close your eyes and just imagine that you are a policymaker or a town planner for a city like Dar es Salaam, and you want to know where your food comes from, how much of it comes from where and when, and what are the implications of the current arrangements and settings and configurations of the food system, the food supply chain, bringing healthy, nutrient-dense foods to your town and your city. And we know these questions are critically important because cities are facing multiple challenges on multiple fronts: climate change, growing inequality, population growth, etc. We also know that, particularly in low and middle income countries, food supply chains are particularly opaque in terms of traceability of foods. And also there are multiple foods in which people can source important nutrients. It's not just a single food, and as a consequence, the picture becomes complex for decision makers, policy makers. And what we are doing in the NutriShed project is innovating upon the food shed approach, which some of you may have heard about. And we're trying to understand whether it is possible to define food sheds, but for nutrients. Is it possible? How do we go about it? What are the implications? What do we find? So today I'll be presenting a number of key insights from this study. And just to start with, I want you to think about nutri-sheds and food sheds similar to contours on a map, defining a river, for example, a watershed or a river. You can have food sheds which are relatively kind of deep and narrow, relatively local food sheds, or relatively wide and regional, where food is coming perhaps from different regions or different countries. Actually, this is a concept that was first referenced nearly 100 years ago. So far in the literature, there have been two main applications of the food shed kind of principle, both in terms of mapping food flows into cities, but also then starting at the city and working backwards to understand the amount of land, the amount of resources needed to feed a city. And we are innovating upon the first of these here. So first of all, trying to identify what are the limiting nutrients within urban communities in terms of underconsumed foods and then the nutrient groups. Then mapping these supplies of these foods, carrying these nutrients, so foods rich in these limiting nutrients, in towards our study communities. And we aim for this method to be repeatable and adaptable and repeatable over multiple seasons as well. So the settings of our study are two urban areas in Ghana: Takoradi on the south coast, a city of around about 1 million people, 4 major food markets within the boundaries, and the town of Asesua on the banks of the Lake Volta, around about 70,000 people, 3 major food markets. And this provides kind of a comparative case study approach. And so far, our method has had 5 key stages, which, as mentioned, we aim for them to be repeatable, adaptable to different seasons and different contexts. The first is a series of indicative dietary surveys. These are led fantastically by the University of Ghana, and we have the experts in the audience. In terms of 24-hour dietary surveys for women and children in households to identify, quantities consumed of different foods, nutrient-dense foods, and then mapping these onto, nutrient compositions using standardized food databases. We then, from this analysis, then mapped the limiting nutrients, which for both cities were found to be vitamin B2, folic acid, iron, and calcium. Then mapped these onto around about 20 foods found to be locally available within our 2 study sites. So here you have kind of little categories. So for example, under folic acid, we had cowpea, orange, tangerine, lemon, and lime. The 5 foods rich in folic acid available within our study sites. And then the kind of meat of the methodology, really, the road intercept survey methodology, building on work that has been pioneered previously across areas such as Mogadishu and also Tamale in northern Ghana, actually conducting short interviews with traders on their way to markets at checkpoints across the different study sites, and asking them what they are carrying, the quantities of food they are carrying, where it was sourced, where it was produced, and where it is flowing to. So you can start to get some spatial kind of dimensions here from the data. Next up, we conducted a series of market and infrastructure surveys, tried to understand the wider enabling environment, presence of cold storage, processing facilities, warehouses within the local communities. And lastly, then everything then became geospatial. So finding coordinates, understanding where these source locations are, which districts, which towns, which villages, then conducting various geospatial geoanalysis in QGIS. So what does our data look like? So first of all, these are all of the different sources for all of the different foods across the 4 different nutrients. We can produce maps of each of the different nutrients. You'll see disaggregated statistics shortly for the different nutrients, just time sensitive. So here are the maps for the different Assessor on the left-hand side, Takoradi on the right-hand side. And a few things to notice. First of all, many sources are clustered around the actual market location itself. These systems do depend upon majorly on local production. You can notice that actually Assessor, all of the food during our road intercept surveys, I neglected to mention, we conducted these road intercept surveys in 2 seasons, the dry season and the wet season in Ghana, and they were for 2 weeks each in each season, and 2 days across those 2 weeks. And we couldn't have enumerators there 24 hours, so they were there on the road, meeting and speaking to traders from 6 a.m. to about midday during the peak of the kind of the rush hour into the market. Sorry, I completely neglected to mention that earlier. So we have a relatively localized NutriShed for Assessor, but Takoradi, you actually see in the wet season, there are 4 international sources, which if you look at the subset of the map, you're actually importing beef through the port via the USA, Brazil, China, and Australia to Ghana. So literally the 4 corners of the planet, as we look at the Eurocentric map at least. And then you can start to plot distances of sources and quantities over space. So on the x-axis, we have the distance from the source of the production for the different foods rich in these different nutrients to the destination. And on the y-axis, you have the cumulative percentage of the supplies, and each dot equals one source on the map. And you can see, essentially, these NutriSheds have different dynamics. These are like the contours on our map. So steeper lines, steeper contours, steeper gradients within the NutriShed. So, for example, for Takoradi in the dry season, around about 100% of food sampled rich in iron were coming within 10 kilometers of Takoradi, local slaughterhouses, and local rearing. And you can also then start to see some seasonal effects. And I just want to, interest of time, just point to the relative dispersion, the relative variation from Takoradi relative to a sessile where the lines are relatively bunched, perhaps reflecting a relatively local food system dependent upon local production, relative to a sessile's relatively diversified, distributed supply chains. I will now get moving quickly, last 90 seconds, just to say we also did these infrastructure surveys trying to understand the presence of different infrastructures within the communities. Essentially, they were underutilized for the foods rich in our 4 limiting nutrients, except for iron. You can see 28 out of 30 and 44 out of 56 in Assessawa and Takoradi, respectively, were being used to store mainly chicken in kind of localized private cold storages in and around the markets. So potential information here for decision makers around what exists and current utilization. I will just click through this and just hopefully we've shown you an interesting methodology and some interesting results, and there's many ways in which this can hopefully help inform regional decision making, planning, thinking about transport, production. There's still lots more work to do. There are also various challenges with this methodology, from stopping traders on the road and conducting interviews, all the way up to the larger kind of representativeness. There are discussions to be had there. Lastly, next steps, just to point to 3 quick ones. Characterization of our nutri-sheds in terms, everything is spatial, so then integrating with secondary data with regards to climate vulnerability, perhaps socio-demographics, perhaps the transportation facilities that exist within these nutri-sheds. Integration of qualitative data in terms of interview data. We conducted a series of key informant interviews to provide more color and explanatory power to the results. And lastly, we plan and really hope to publish and make our data sets publicly available to supplement similar studies that have been mapping food flows across Africa and beyond. Thank you, Simon. And with that, I'll say thank you.
Thank you, Gregory. That was a fantastic presentation, and you kept well with the time. So slowly we are shifting from food security to nutrient security, and he showed us a way to map the nutrients, one of the way to map the food environments. Our next presenter is going to talk more about spatial methods in relation with mapping the food environments. She's from Purdue University. I invite Nilupa Gunaratna to give her presentation, and hope you keep up with the time. Just one notification that we will have all the questions towards the end of the session. So please note a lot of questions, and I'm sure you have many of them. So please go ahead, Nilupa.
All right, thank you, and great. Thank you. Good afternoon, everybody. Thank you all for being here. Glad to be able to share this work. I want to start by acknowledging my many colleagues who are working on this project. We're part of a Imana-funded project called FS, which is developing methods for external food environment surveillance systems. And as we've been hearing all throughout the week, the food environment is that interface between us and food systems, which provide us with options to make dietary choices. So they provide kind of limits on what we're able to choose and have available to us, and so ultimately affect our choices, our diets, and our health. I also want to recognize that they're also an important source of livelihood for many people around the world. And a lot of research has been done. Good research work has been done on spatial variation in food environments, and it's been shown that spatial variation affects food choices and eating behaviors, and as a consequence will affect diets, nutrition, and health. And this has been studied at various geographic scales, especially in high-income countries. But what about temporal variation? And that's what I'd like to talk to you about today. So many of the studies that have been done, many of them are either cross-sectional or they look at seasonal variation. There's some good exceptions that are being presented here. And this is an important issue, especially when we have a preponderance of informal vendors. We can see changes that are more rapid and more frequent than this. And Ramya Ambikapati, who's a colleague of mine on this project and will be presenting tomorrow about some of those issues in some detail. But we know that temporal variation can happen on these smaller scales, and research largely in high-income countries have shown that these kinds of even within day variations in food choices and behaviors can affect health outcomes. So how can we understand what some of these temporal patterns might be? So one thing we wanted to address as we wanted to explore to this is looking at research designs to study temporal variations at varying scales in food environments. And we took our inspiration from ecology and tried to adapt the idea of a transect. So a transect is a method used in ecology where you start in one place and you move across space in a line and you make observations. And it's a good tool to systematically collect data, to look at spatial patterns, quantify diversity, and compare environments. And it's especially valuable when there is spatial variation. So can we apply this to time? So we developed this approach of looking at temporal transects. So instead of moving across space, we fix space and we move across time and sample data in a structured sort of way. And instead of organisms, plants, and animals, we're looking at food vendors and other time-varying parts of the food environment. And now we're interested in looking at change across time. Working great. So we applied this approach in 2 counties in Kenya, Machakos and Kirinyaga counties, which are different in agroecologies, but they were both selected because they have a highly increasing burden of non-communicable diseases, but are different environments. And we started in these secondary cities that are the county seats, and we moved in a gradient from urban to rural. And for the sake of this part of the project, we identified some specific areas of interest. So 6 places within this urban to rural gradient in each county, which are highlighted here in Machakos and in Kirinyaga. And in each of these 12 spots, we did temporal transects, which meant that we showed up in that spot before any other food vendor did early in the morning, and we stayed all day until the last food vendor left. And by using a structured tool, we collected data every hour on the hour. And that tool was a rapid assessment tool that captured location characteristics of that particular day, characteristics of vendors, including the people, as well as the structures that they worked in, and then various aspects of what they were selling. We spent quite a time developing and identifying here 37 food groups. We later expanded that to 39 that captured both healthy and less healthy foods, both cooked, ready to eat, and we also collected data on processing, packaging, marketing, branding, and all of that. We did this temporal transect at each location on 4 different days that were not consecutive, trying to capture weekdays, weekends, market days, and so on, and that led to a rather large data set. The assessment was quite rapid. It took just under 3 minutes, a typical observation, and it was all public observation. From that, we can construct metrics that could be assessed at a vendor level or at a point level, where the point level reflects more of the consumer experience. We also tried to adapt some common metrics that you might all be familiar with to apply to vendors rather than consumers. When we're analyzing the data, there are different approaches. The key observation is that our data are correlated from time to time. And so you can look at that using a kind of a standard longitudinal model where we look at differences from hour to hour, to look at within day variation. You can look at interactions with the type of day, to look at between day variation, and you can look at interactions with the different spots to look at spatial variation of temporal patterns. You can also use time series approaches, and there are many different ways to go about this. The most straightforward is to just look at stationarity, which just looks for changes over time in a time series. There's some kind of standard tests that are available for that. In our data, we had a limited number of data points. There's only so many hours in the day, but the method can be easily adapted to have multiple consecutive days. So just in the interest of time, I want mostly to first and foremost, to share the method with you, to give you an example of the sorts of observations that you can make from this kind of data. So we looked at many metrics, and I'm just going to show you 3 of them to illustrate what the method can tell us and what they can't, and spend a little time on this first one. So this one is the diversity of food groups, the number of food groups that a vendor is selling, so the average food groups per vendor. Looking at one particular location on 4 different days. Those are the 4 different curves that you see on here. And we look at that pattern from 5 a.m. to 2200 or 10 p.m. And so what you see here is the diversity of vendors' offerings are pretty high in the morning. They drop in the afternoon, and then they go up again substantially in the evening. So a few observations there. If you collected data in the morning, you'd get a very different picture of what vendors sell than if you had collected that data in the afternoon. If you had collected data from morning until afternoon, a full day of work, you would actually get a changing story while you're in the process of data collection. So these would, and all of that would miss what happens in the evening, which is really important for consumers in particular. Here's another particular site where we looked at 4 different days in a peri-urban location. And what you see here is across the days, a lot of between day variation in the morning and less so in the evening, but the days are not necessarily the same. Here's another example where we look at spots that were on roadsides or street sides, but we're looking across urbanicity, and we see what we see in subsequent data collection, that vendors in urban areas tend to be more specialists. They have less diverse offerings. That's less so in peri-urban and rurals, but you see different patterns. And peri-urban is distinct, often distinct from urban and rural. Here's another place where we looked at within the urban setting, but in 3 different locations. And again, you find even within that urban setting, different places have very different temporal patterns. Just very quickly, a few other metrics. We looked at male and female participation among these in food vending. And what we find is that with increasing urbanicity, we tend to find more male participation. And if we look within a day, that participation varies within a day, particularly in urban settings where we often see greater male participation, less female participation, especially in the early mornings and in that very active evening period. And then one more. We looked at the food groups that are often under the metric of NCD risk. So that's sweets and cakes, grain-based sweets, processed meats, sugar-sweetened beverages, and the availability of those. And also within a day and between days, we do see significant differences on the availability of these foods, where days and weekends tend to have different patterns. Even though we worked all the way from urban to rural around these secondary cities, we do see a high penetration of some of these unhealthy foods. So moving very quickly, so just give you some illustrative examples here of how food environment metrics can really vary across time on very small scales. And that means that timing and duration of data collection do matter and is something that we need to pay attention to. The time-varying food environment would imply that food choices and eating behaviors are also time-varying, and that's something we don't always consider in our research. And that's something we perhaps need to give attention to. This has been a really effective method for us to assess these kinds of differences and also to think about when we need to collect data. So thank you very much.
Thank you, Nilupa. That was a fantastic presentation and connecting different time points of the value chain, starting from vendors to actual consumers. We have our first presenter here, Brighton Mubumi, and he will be presenting, talking about humanitarian emergencies and post production losses, how to reduce and what are the methods. He's from Zimbabwe University. I welcome Brighton. There are 10 minutes for you.
Good afternoon, ladies and gentlemen. I represent a fairly large group. Sorry, I represent a fairly large group, and I'm happy to announce that one of the group members is actually here. That's Aurelie. She's actually the project leader. So we'll share some experiences on a tool that we're trying to develop to estimate nutritional post-harvest losses, focusing on humanitarian aid situations. So that's the outline, my presentation. So we're trying to look at the food system and what disruptions happen in certain, in particular locations. And we also want to look at the post-harvest losses that happen in those systems. And associated with that is the nutritional losses and also food aid interventions. And this project is actually targeted at Uganda and in East Africa and Zimbabwe in Southern Africa. So I think I will move on just to give you a bit of historical context. We have worked on this model before, but in a different setting where we had a normal setting with the farmers who produce normally and store their crops. And we actually developed a model for that. But we then also realized that we do have a system where the metrics are not documented, they are not known, particularly in terms of the humanitarian setting. So we're trying to apply that model, refine it in humanitarian context. So previously, we looked at beans, we looked at maize. Maize was the common denominator there, but we also had sweet potatoes, the orange fleshed, because it's focused on nutrition. So in this particular investigation, we're trying to develop an understanding of how different factors affect nutrient losses and how different families access nutrition or nutrients, then identify critical points where post-harvest losses occur, but at the same time look at where we can have disruptions and then estimate where nutrient losses are happening in terms of quantity and quality, and then disseminate the findings. So this kind of summarize the partnership arrangement and the focal nutrients there. And by way of methodology, we started off looking at a conceptual framework and then look at the context in which there are different disruptions and crises. Then we looked at, in phase 2, we looked at the value chains for specific crops, important especially in Uganda and Zimbabwe, but in a humanitarian setting, and identify those points where nutrient loss is occurring. Then in phase 3, we then actually sought to estimate the food amounts in quantity, and also estimate nutrient losses that is in quality, and then use that data to generate a predictive model, and then upload this model online so that it can be accessed and used by the globe. So this just gives you an idea of the value chain steps that we followed, and in terms of the application and who is actually managing that. So there are various steps in terms of the value chains, from harvesting to household storage, and those steps, they apply to both humanitarian and the normal households, which we call the host community. And then this is beyond WFP's jurisdiction, because WFP is the major agent in food distribution. And then we look at the next phase, where there's aggregation and storage and transportation. This is where WFP comes in, and it looks at, it applies actually both to humanitarian settings as well. No, this is specific to humanitarian settings. And losses in this case are very unlikely, because these tracks are actually tracked throughout. And then we have what one might call household storage, which is within the host community and also the humanitarian value chain. So this is beyond WFP. So this is just to give you an idea of the package that we have. One thing that we found was that there's been a reduced food aid in both countries. And there are two categories that we observed. The most vulnerable is receiving $8 per month per person. This is in Uganda. And in the moderately vulnerable, it's about half that amount. In Zimbabwe, we have the most vulnerable who are just arriving. They have a different package there. It's mainly focusing on food. But those who have settled for quite some time, they are given partly food and cash to cater for other livelihood needs. And there is also supplementary feeding for the vulnerable groups. But what we found, this supply to vulnerable groups is actually, the food is actually eaten by everyone, practically at household level. It's not restricted to those household groups. So this is the perceived losses. Just extracted some data for Uganda. And you can see that women are saying that, yes, there are a lot of losses from harvesting to packaging, and at drying is both men and women, especially in the communities of concern. So we came up with some strategies to how we can reduce these post-harvest losses. So we reckon that drying and processing is a very important intervention, and also hermetic technologies. Maybe I need to look at some dynamics. Women typically most affected because they care for children and they care for the household. We also see that men are also affected in a way, because as heads of the family, when food insecurity hits, they tend to actually hide in drinking, and that can be quite problematic. So gender vulnerability in food insecure households is actually determined by traditional gender roles. Those are some of the summary of some of the effects of reduced food access, family level, ranging from divorces, violence, school dropouts, theft, prostitution, suicide. There's also clandestine purchase of groceries to prevent people from coming back later to beg. So there are a lot of things happening there. And these are some of the key disruptions. Drought is key. And we reckon that, like in Zimbabwe, for this particular community, they can't produce without irrigation. So when there's drought, there's no food. Ironically, in Uganda, there are floods. So, but they also experience drought. Conflict, there's a lot of influx new people coming in, and that causes problems in terms of land allocation because they are moving away from handouts to a livelihood approach where they're supposed to produce their own food. Pests like the fall armyworm is also quite key, and of course theft. So these are some of the future directions which you can look at. I just want to give you an idea what is actually happening in terms of transportation. It's not just the grain, but also food itself. And then this is the typical food distribution center managed by WFP. And in this case, sometimes they get meal, ground flour, but in this particular case, they were actually getting grain in the form of wheat. So yeah, these are some of the key partners who we were working with, and that's the team that did this research. So what I didn't mention there is we are still doing some storage trials where we're actually measuring nutrients for a long period, at least 6 months. Otherwise, thank you very much for your attention.
Thank you, Brighton. I think post-harvest losses contribute the most to overall food system losses, and you brought out different aspects of it and enlightened. Our next two presentations are going to be online, out of which the first one, Madhuvanti Murphy, she's from the University of West Indies, and she's going to I think we have Valerie here, who's the last speaker which is mentioned, and she's going to speak first. Again, about the food environments and mapping toolkit. She's from the RTI International. I welcome you, Valerie, for your presentation. I think you can go ahead. Yeah.
Okay, well, good afternoon, everyone. I'm happy to be here. So I'm presenting on behalf of the team you see on the slide, and we'll be talking about applying RTI's Food Environment Toolkit in market systems programs to ensure a focus on improving healthy diets. Next slide, please. Okay, so about 4 years ago, RTI provided some internal funding to develop a food environment toolkit. The purpose of the toolkit is to facilitate the integration of agricultural market systems and nutrition programming to improve consumption of nutritious foods by identifying food choice drivers, identifying opportunities or gaps in the market system, and collaborating with market system actors to align their offerings with consumer preferences. The toolkit is based on Turner's Food Environment Framework, and it has 3 components that you see on the left side of the slide. So it has a nutritious food selection matrix, a personal food environment assessment, an external food environment assessment. And then once all those findings are analyzed, they're shared with market actors through a series of workshops so they can identify barriers and opportunities and work with the program to implement changes. Next slide, please. So the example that I'm going to use today, we actually did a learning lab last week as part of this conference where we went through each of the tools with people in the learning lab and talked about the details of how they're used. So this presentation today is focusing on results that we have from Ethiopia Transforming Agriculture project. That project is aimed at increasing access to healthy diets, especially for women and children, by facilitating modifications to the food environment. You can see from the map on the right side of the slide, all of the areas that are gray and in color, those are the project areas. So it's quite a large project. It covers 5 agroecological clusters across Ethiopia with the aim of reaching 7 million people. Next slide, please. Okay, so first to talk a little bit about the nutritious food selection matrix. And throughout this presentation, I'm going to focus on dairy, the dairy value chain, dairy commodities. But that wouldn't be the only commodity that the project is focusing on. But for the sake of the presentation, I'll stick with that. So the first step is to work with the program team and fill out this nutritious food selection matrix. So the team would identify several different commodities, and they would fill this out for each one of those commodities. So part of it is trying to see, a big part of it is trying to see, can this food fill some sort of nutrition or nutrient gap, especially for women and children. So we try to focus on things like dairy, animal source foods, chickpeas, groundnuts, and others that could fill nutrient gaps and that aren't just staple foods. So using the dairy example, we see that yes, dairy can be a good source of nutrients, and it's underconsumed by women and children in many parts of Ethiopia. It is possible to increase domestic supply of dairy, and there's a big gap in the availability of dairy in Ethiopia. So there's a large amount of import of dairy products, and value chain actors do want to increase the local supply. In terms of functionality of the value chain, it is very variable across different parts of the country, and depends somewhat on presence of milk collection centers in different locations. Desirability and convenience could be increased through value addition, and affordability could be increased through higher production. Women are already highly engaged in the dairy value chain. So in this particular project, there's an emphasis on involving women. And so that's an important component for this project. And then we also looked at the enabling environment. So in Ethiopia, there is a dairy board, which is a positive element of the enabling environment, but there are also taxes on feed, which are detrimental because availability could be increased if feed was more available. So there's sort of two sides to that. And so we look at all of these and kind of give a score. And in this case, you see lots of green. So dairy is a good commodity for this project to focus on based on the nutrition food selection matrix. Next slide, please. Okay, so in terms of methods, for the personal food environment assessment, we did a survey of 1,000 women with a child less than 5, 200 women per agroecological zone. The next step after selecting the commodities using the nutrition food selection matrix is to work with the team to identify what are the specific foods that are available in markets that are related to that commodity. So you see here on the left side, raw milk, boiled milk, sour milk, and so on. And we ask a whole series of questions. So the questions in blue are asked for each one of those types of dairy products: frequency of purchase, place of purchase, and so on. In addition, there are some overarching questions about food expenditures and market access. Next slide. Okay, so these are some of the results from About Dairy from Ethiopia Transforming Ag. So you can see in the bar chart, for each commodity, the first question in the questionnaire is about whether the household buys this type of product at all. So you can see on the far left that quite a few households are not buying dairy at all, particularly in the Tana and the northern clusters. However, among those who do buy who do buy dairy, raw milk is the most commonly purchased type of dairy. So you see in the blue panel on the right, an example of some of the results that we have specifically for raw milk. So we find that women say that they purchase either every day or a few times per week across all the clusters. In all the clusters, they said that they buy milk from farmers' homes, so not actually directly through retail markets per se. Dairy shop is the location where they buy in northern and southern cluster. In some of the clusters, they don't have any packaging for the product, so it means they're coming with their own container and they're buying it with that. And 2 of the clusters, plastic bottles were used for packaging. Women said that the vendor space, the cleanliness of the vendor space was very important to them. Other factors that affect their purchasing were the taste of the milk, the quality, and the fact that it's considered a healthy or nutritious food. And the biggest barrier across all the clusters was cost. Next slide, please. Okay, thank you. So the external food environment methods involved key informant interviews with retailers, wholesalers, processors, and regulatory agencies. So in the table on the left side of the slide, you can see which types of questions from Turner's food environment framework were asked to each of the types of participants. And in the bar chart, you can see the number of key informant interviews that were conducted with those different types of participants. So in this case, particularly retailers and processors were the main people interviewed, and there were also fewer interviews with wholesalers and regulatory agents. Next slide, please. So in terms of results for the external food environment related to raw milk, again, we found that in terms of availability, in Jimma and northern clusters, demand outstrips supply, while in southern and Tana clusters, supply is good, but demand is low during fasting periods. So in many parts of Ethiopia, people are members of the Ethiopian Orthodox Church, and they have more than 200 fasting days per year. That doesn't mean that they don't eat at all, but they don't eat animal source foods during those days. So it means they wouldn't consume milk. In terms of prices, they vary greatly by cluster and also during holidays and non-fasting periods. So prices tend to be higher during holidays and non-fasting periods. In terms
Valerie, we have 2 minutes to summarize.
Okay, thank you. In terms of vendor and product properties, consumers prefer milk from local cows. They want it to be thick. They want it to be fresh. The flavor is important to them. And retailers aim to have a good supply, good quality, and good customer service. In terms of marketing, in some areas, they give out free gifts and use banners. And in others, they promote the nutrition benefits. In general, quality assurance for milk is not common. Next slide, please. So all that information was shared with the market actors, and these are some of the ways the project has been making changes to improve the dairy marketing. So one of the big things this project does is provide grants to private sector actors. So they're giving grants to milk collection centers to improve their efficiency, and also for milk collection centers to support farmers with services like feed and veterinary services that can increase production and thereby increase availability and reduce prices. They're also working with milk collection centers on a quality-based payment system. So when smallholder farmers come to the milk collection centers, the milk is tested, and if it's good quality, they get paid more, which improves the quality overall and is kind of a virtuous cycle. They're providing training for processors and vendors on hygiene and making sure that their spaces are clean, also to increase desirability. In addition to trying to improve availability and prices, they're also working with vendors to sell milk in smaller packages so that the cost would be lower and low-income households would be able to afford it.
Valerie, we will need to stop the session here because we are over timing.
Okay, thank you.
Thank you so much. And we go ahead with the clap for Emily. Thank you so much. And go ahead with the last presentation by Madhuvanti Murphy on mapping the unhealthy foods in 4 countries. Please go ahead and kindly keep up with the time.
Yes, thank you everyone for the opportunity to present our work. We're trying to understand the drivers of unhealthy eating within food systems across small island states. Next slide. And this is a National Institute for Health Research funded group, which began in 2022. The project is actually now moving into its final year. It's known as Global CIFA. Next slide. So just a bit on the overall goal of the project. So what we're trying to understand is the potential for improving household diet, nutrition, and food security. to reduce the burden of nutrition-related diseases, such as non-communicable diseases, by promoting increased community-based food production based on agroecological principles. So it's quite a mouthful, but think human health and planetary health. And in recent years, Small Island states has had a focus on localizing food systems in order to reduce their food imports of, particularly of ultra-processed foods, because of the link to those to obesity and non-communicable diseases. So it's important for us to understand food systems in order to link the factors affecting human health and planetary health. And this will help us to determine where to intervene within food systems to create positive change. So our aim here for this piece of the project was to understand and compare the drivers of unhealthy diets in small island states through mapping the complex dynamic systems in each of our settings. Next slide. So just a quick look at the locations of our sites. As I mentioned, they're small island states. So we have two that are in the Caribbean, which are St. Lucia and St. Vincent and the Grenadines. And then on the Pacific Asian side, we have the Philippines and Fiji. Next slide. So now, sorry for a quick overview of our methods. And a key part of understanding food systems is the way we're exploring. We're using a systems approach. It's a transdisciplinary process, and it's a way of thinking so that we can understand health as a system of structured relationships and understand the value of diverse methodologies that exist for learning how those systems are organized. Next slide. So key to understanding systems is knowing that they are not linear. So they're made up of sets of people or organizations, and you're really trying to understand their interconnectedness, as the entire system cannot be understood through looking at individual components. And we love to use this picture that I have on the side here of an elephant. And if people are looking at it from different areas without looking at the whole thing holistically, they're only seeing the one part that they see, and they can then interpret it as very different things. So instead of looking at just the individual components, we're looking at this holistic picture and understanding things like feedback loops and time delays within the system. Next slide. So a little bit about our methods and how we went through to create these systems maps that you'll see shortly. So the start of the process is through group model building. And this is the process where we start asking ourselves, what's the primary problem? What is it that we want to change in the system? And who needs to be at the table? Which are the stakeholders that actually can help with this change? And then we look to map out the causes and consequences of our reference point. In this case, we're looking at unhealthy diets. Next slide. And this is just an example of what it looks like. You'll see in the background, it's quite a process. It's quite a messy process. And what we end up doing is mapping out by drawing through what everyone has told us. And then we can actually put these into a program called VenSim to clean it up a bit. But just to say, we carried out 4 setting-specific workshops. Each of those had 15 to 20 stakeholders per setting. This is very much a participatory approach using key stakeholders from multiple sectors. So in our case, we used, private sector, public sector, government, non-government organizations, and these were done in each setting between 2023 and 2024. So you're looking at farmers, policymakers, academics, food vendors, etc. And as I mentioned, we use VenSim to create these causal loop diagrams and to sort of clean up the maps so that it would be easier for us to identify leverage points for intervention. So just getting into the food systems maps themselves. So what we aim to do with these maps is to understand core feedback loops and how we can intervene in those loops to make changes to unhealthy eating. But what we've realized is that we've focused on the similarities within these models, but less so on the differences. What we're also realizing is that these differences, within these differences, many times these are variables that may be on the periphery of some of our causal loop maps. But these are just as important, and by not addressing them, we can undermine the ability to make impactful change because of the weight that some of these carry. So you'll see right now, I can use the St. Vincent and the Grenadines map as an example. But sorry, if you can go back a slide, we're still on the St. Vincent one. Thank you. So just to say, all settings have similar core drivers that we found for these particular settings. Core drivers of unhealthy eating, usually around things like marketing of unhealthy products by private sector, the availability of locally grown foods depending on land access or climate change, and in particular, things like local farmers having to compete with imported foods, including fruit and vegetables coming from larger countries where production is heavily subsidized, which makes those items cheaper than the local options when they enter the local market. So in looking at this map of St. Vincent and the Grenadines, if you look at a very basic causal loop, you may not be able to see this very clearly, but I'll just speak it through. Unhealthy diets, which is our reference point, that's a square in the middle. Those unhealthy diets can lead to a rise in non-communicable diseases, which can lead to a loss in productivity, which could lead to a loss of disposable income. That leads to purchasing more affordable food, which tends to be less nutritional. Most of the cheaper foods are the unhealthy foods. And that then loops back to continuing eating an unhealthy diet. So we can try and break this intervention perhaps around the area of affordability of unhealthy foods, maybe putting higher taxes, the hope that it leads to less unhealthy diet and more positive knock-on effects. But what we also see emerging in St. Vincent, and that's where these circles are, is the role of tourism as a driver of unhealthy eating through food imports for hotels and offshore schools that then spill over into the local market. So that's an issue that we have to look at here. That's not, quite in the middle of that map. Next slide. And then we see in Fiji, again, a very similar map in terms of, getting to the bottom of unhealthy diet and some similar issues around agriculture, marketing, and understanding sort of foods and what's considered affordable and available. But what we see in Fiji, if you could click to the next slide, is that cultural experiences and expectations, and particularly through things like peer pressure, and things like what are considered culturally appropriate, which is something like kava drinking. So kava is a plant-based psychoactive beverage that's produced from root crops in Fiji. Those can lead to unhealthy food choices or the acceptance of unhealthy food choices. So let's go on to the next slide. And then again, the map for St. Lucia, you'll see, again, another busy map, but with the same sort of core aspects of it. But if you look at the next slide, where I've circled the area that we want to focus on, what we found in St. Lucia is that policies around how agricultural land is accessed and how it's used. So for example, whether land is used for agriculture or used for construction and development, especially with things like a housing boom or tourism sector boom, those, the ability to access and use that land that's supposed to be for agriculture, and as well then the knock-on effects of being able to access farming resources, is something that's very politically controlled. So really understanding those policies and how to intervene for those policies, and get political buy-in at all levels, because it's not just about land access. We've also seen it in St. Lucia around things like trade, really affects, what can happen in this type of map. Then the next slide. And here's the Philippines. Again, the core drivers are basically around the same kinds of ideas. But then if you click to the next slide, we'll see that there's one thing here, and it's very interesting because this was something in the map for the Philippines where they've had dotted lines. So kind of indicating that, these are things that are threaded throughout the whole causal loop map. And that's the lack of nutritional education and nutritional education resources, and really understanding then how that can undermine the entire system. Next slide. So really what we're trying to understand then is how do social, political, and cultural factors affect the core model? Because these are the things that are underlying a lot of our models. And what we're finding is that's where the differences are emerging. And these are very nuanced depending on the setting. So in asking ourselves this question about how it affects the core model, and how it affects our ability to intervene within the feedback loops of the model, it makes us think about the areas that are more difficult to intervene. So, with things like, excuse me, with policy, the need for a policy window, the need for political will. If we don't have those things, it makes it very difficult to make other interventions happen as well. things like cultural factors, as we saw in Fiji, take long-term change, changing cultural norms, even things like what we saw then in the Philippines, trying to change education and education resources across generations, because it's not just general public education, but it's definitely across different age groups. And the reason why these are important, even though they are sort of on the periphery of a lot of the maps we've just seen, is that these are areas that carry a lot of weight, and they can still impact and make or break whether interventions that we consider more low-hanging fruit can actually have a high impact. Next slide. So this is just sorry, this slide before, it was just to show our website, communityfoodplanetaryhealth.org on the previous
Thank you,
slide.
Madhuvanti. Can
Sorry,
you hear us?
I can hear
We'll
you.
have to stop here.
Okay, I just wanted to go to the previous slide so people can see the QR code if they would
We'll
like
have
to.
to stop here and
Okay.
considering the time, sorry.
Yeah, no problem. Thank you.
Thank you, and a round of applause for all 5 of them. We have 10 minutes for question answers, and I request all the presenters come in sequence and please be here on the podium. And we will take first 5 questions from in person and 2 questions online. So can we go ahead with first 5 questions? Kindly introduce yourself very briefly and please let us know whom you are addressing the question. Please raise your hand if you have, yeah, sorry.
Hi, I'm Bronwyn Powell, and my question is for Cooper. Thanks. It's great to see food shed work continuing here in this forum. I'm curious what you think the policy implications are of your work.
Second question, please.
All right. Thank you so much for the presentation. My question relates to the study in Ghana, but also one to Mathe. You are talking about policy implications which are not yet finalized, mostly the political, cultural related public policy, and how those affect the results that you have really highlighted. Maybe if you can shed a little bit light relating to that, that would be good. Relating to the study in Ghana, it has completely shown the spatial distribution relating to these markets. I would want to know more the role of infrastructure, because sometimes you'd assume that products are coming from this route just because a bridge is not there and all that kind of stuff. I'm not sure if those barriers were looked into. Do you think it's a reflection of just demand and supply, or it might be beyond that? Issues about the law of doing business, basically within Ghana, taxation issues, whether it's informal or formal markets that are really informal vendors or formal, would also play a role in the actual distribution. Ghana is basically known as a country that is rich in terms of production systems, but we'll see that some of the products, some of the products from there, like iron, are almost really being taken from far away. What are the implications of that, and what would be the public policy implications relating to the same? Thank you.
Please kindly ask quick questions. We have only 7 minutes. 2 more? 2 more? 3 more, sorry.
Hello, I'm Julia De Bruyne from the World Vegetable Centre. I had a question for Valerie. I was just wondering if you could speak a bit more to the scope of the personal food environment tool that you described. So it looked like some of that might be more what we might consider external, sort of things like product properties, looking at packaging and that sort of thing. And there might be some personal factors around convenience or food knowledge or other things that maybe were not captured. So maybe, yeah, it'd be great if you could talk a bit more about that personal food environment assessment.
Thank you. My name is Sam from the University of Greenwich, and my question is on the Kenyan study. The 2 areas where you did your research, Kirinyaga and Machakos, are very different in terms of production. Kenyatta being a hub where a lot of food, even in Nairobi, gets to Nairobi. So how, even though your research is on the temporal assessment, how does the production unique characteristics of the two areas influence the food groups and the number and variety? Thank you.
Last question.
Hi, I'm Shivani. I had a question for Valerie. You mentioned that outstrips you mentioned that demand outstrips supply milk. Does that mean milk is imported from neighboring countries or other countries in Ethiopia? I was just curious because I have looked at the World Integrated Trade Solutions data and found some relevant findings there. And also, do you plan to examine dairy consumption among households with school-aged children? I feel that group might show a different picture. That's it. Thank you.
Thank you very much. And we can start answering with Georgie. Can you please go ahead?
Yeah, sure. Thank you for the questions. The policy implications question, yeah, absolutely excellent. We've got a lot of data, and there's a number of ways it can be analyzed. So far, we've done a lot of mapping, and there's a process of collecting that data and digitizing and mapping, and now it's right. You know, a lot of it. What does it mean? I would say probably 3 or 4 key policy implications. The first is, at the same time as collecting this quantitative kind of mapping data, we've been working with local stakeholders, kind of local organizations that run the markets, the transport unions, all the way up to, I think, Department of Agri, perhaps in Ghana, through the University of Ghana. And just not only getting them to think about where the food comes from, how it comes, where it comes, and the seasonality. Also, hopefully, a methodology that we will need to convince them, but is worth looking at, taking seriously, in order to start actually tracking and tracing where fresh food comes from. A further kind of expanding out from the study sites, just thinking about how regions may need to cooperate together across seasons. Something we're quite interested in is, for example, I'm personally quite interested in is how the food system may change, Nutri-Sheds may change under extreme weather conditions. So what can different regions of Ghana do to collaborate and enable these food flows to happen? I'm really happy to chat more though, and it's something we're really trying to work on and then think about the dissemination back to local stakeholders and more broadly. But yeah, happy to chat more, absolutely. Just in terms of the infrastructure question, it's a great question. If we were a bit more skilled as a team at GIS, if I was a bit more skilled, we'd have these flows routing through the roads, basically. You'll see that we've mapped them across Ghana currently as straight lines. And it's a little bit currently beyond me and my GIS capabilities to route these through roads where not every road in a secondary data shapefile matches to where the markets and where the source locations are. So, but absolutely, we know that infrastructure plays a key role. And something we'll be doing using secondary data is trying to understand where these choke points exist. So are there particular sources that are particularly dependent upon certain roads, certain road types? That data exists, whether it's OpenStreetMap, whether it's the United Nations, OCHA. So yeah, but happy to talk more, and I'll pass over now for time.
Thank you very much for that answer. After that, can we go along with Maddie and followed by Valerie? I think you have 2 questions. Maddie, would you like to answer?
Sure, yes. And I think my question was also regarding policy. And I think to answer your question, it's really around the type of method that we're using. And I think it's the beauty of using system science and using group model building as a method to get to where to intervene. Because as part of this process, especially from the political side, when we invite or the stakeholders we have in the room, particularly from government, tend to be from different areas of government. So, what we've come to realize clearly is that, policies are prioritized, across governments in different areas. So we try to have folks from health, from agriculture, from education, from trade in the room alongside, as we mentioned, folks from non-governmental organizations, people who are essentially representing the general public as well, and representing different stakeholders. So that helps us in terms of then advocating for what policies we see as being priority, to help create that policy window that I mentioned. And it's really important, as we realize as well, to have both not just the top down, which happens a lot of times, but the bottom up, because as long as there's a demand as well, for certain types of policies, then that also helps with creating that policy window at a particular time. So this process of group model building actually helps change how people see what their priorities are, when we go through this. Thank you.
Thank you. Valerie, kindly go ahead. You have 2
Okay,
questions.
thank you. Thanks for the questions. So in terms of the personal food environment tool, there are a series of questions related to desirability that are based on drivers of food choice tools. So there's a series of 12 questions that are based on that and get more at desirability. We also use, and I didn't talk about this in the presentation, but we also use focus group discussions as another method of collecting data as part of the personal food environment. So that's another way for us to get at some of these issues like convenience and desirability. And I'm happy to talk with you more offline if you want some more details. In terms of the other question about demand outstripping supply, there is a net import of milk into Ethiopia. So there's definitely some areas of the country where there's not enough supply and it's being imported from out of the country. And then in terms of the question about measuring dairy consumption in school-age children, this project is funded by USAID and is still going on, but it's, the life of this project is somewhat unknown at this point. So I don't know if I can really answer that, and I don't know if the project will have the opportunity to do that. But thank you.
Thank you, Valerie. Can we go up with Nilupama last answer?
Sure. Yes, thank you for that question about the selection of the counties, because our project is really focused on developing methods. We wanted to have sites that were quite different so that our methods we can show that they're robust over different types of environments. So we purposely picked those 2 counties for having a fair degree of child stunting, but also overweight and obesity in adult women. So there was this double burden that was high, as well as high rates of some non-communicable diseases that are diet related. But at the same time, agroecologically, as you probably know, they're quite different. So one is wetter, has more cash crops, has a dairy industry, that's Kirinyaga, whereas Machakos is drier, and has other sorts of crops and so on. Another big difference actually in those communities is water quality, drinking water quality. And so one of our 37 and now 39 food groups is actually water, because people are, even of various income scales, are purchasing water for drinking. So yes, so that was intentional.
Thank you. And we have 2 online questions, which I'm going to take. First one is for Valerie. How do we stop import of things from and use more local products? That is about the 4th presenter. And the other one is for Nilupama. How does the food access and combat potential repetition of data recollected from the food vendors? So how to combat that? If it is not clear, it's how does the tool access and combat the potential repetition of data? Repetition of data. So Valerie, can you kindly go ahead with your answer?
Sure. Yeah, and I don't know if the goal of the program is really to stop the importing entirely of products. I don't know if that would really be possible. But one of the goals is to try to increase local production and so increasing availability from local suppliers. So that is a goal of the project.
Thank you, Nilupama.
Great. Yes, that is a really good question. So when we're doing temporal transects, we're doing observations hour to hour, and we are not individually tracking vendors. One is that this is all public observation, and per IRB, we want to make sure if we're following individual people's behaviors over time. That's a different question for IRB that we didn't post. The other is that it's a higher burden keeping track of a large number of vendors individually and tracking them over time. So to reduce that burden, we were just kind of basically like their panels at each time, which means that there's repetition and we can't track them over time. It would be lovely if we could. It would take more resources to track individual vendors hour by hour, and you could do more with that data. But because we were interested in these kinds of rapid assessments so we can make decisions, this is really about making decisions about when we should be collecting data, when we were interested in different sorts of outcomes. That was useful. There are kind of methods. So we have to use some of those time series and longitudinal methods. There could be more possibilities if we're able to individually track. Yeah.
We can have last burning question from the audience. One last question. We have 3 minutes. Do we have any question from the audience in person? Here.
Yeah, just to follow up on the transit question, did you see changes in your customer base? Are you getting more workers in the evening and more students at a certain time of day? Were there changes in the customer base as well as the products?
So again, for IRB reasons, we focused on vendors. We don't monitor customer behavior. That would require consent to collect data on behavior as opposed to just presence or absence. That would be tricky. But we are doing other research where we are going to have, interviews of the vendors themselves so we can get more in depth. We wanted to see what was possible and what can be learned from actual just plain observation to allow rapid assessments. And one of the things we did, another one of our food groups was invisible. So there's not everything that we can capture by public observation.
Thank you very much to all the speakers and also to the audience for your patient hearing. Let's have a round of applause and let us close the session. Thank you for keeping up the time. That ends the session and we can discuss over the conference if you have more discussions to make. Thank you very much and we can go to the next session. Yeah.